the principal component analysis of red wines. This data set I already presented to you in the last videos of the series. We have the data set containing 11 physicochemical properties of red wines. And these red wines have been characterized using 11 physicochemical properties, and these red wines also have a group variable. This group variable is their quality. For example, a very bad wine has quality 1, and a good wine has quality 10. The data set was shown here. You might assignate this column as a character. It is the group variable, and now you can run the principal component analysis. I already loaded, installed my packages, and I already loaded these packages. I don't show this procedure in the video because when I type these commands, until the project launch, run these programs, it might take a lot of time. So I am going to type in the mainframe principal component analysis Shiny dataset, and my principal component analysis will be carried off. So I am going to the mainframe of Commander, and I'm going to type PCA Shiny dataset. Now the principal component analysis of my dataset will be loaded in my browser. In this case, Microsoft Excel. But you might do it in any other browser. Well, in here we have the scores plot and the loadings plot, or simply the graphic of individuals and the graphic of the variables. My original variables were projected in the score plots, also known as graph of variables, and my samples were projected in this new space that was constructed using my 11 physicochemical properties. Like this, I don't see any useful information. So I'm going to PCA parameters. I'm going to graphical options. And now I will have labels for individuals selected by color points according qualitative variable. I will use, qualitative variable. I just have one qualitative variable, that is red wine class. I will take off individuals, and I will make the points look bigger than they are. Look at that. I will select the color points according to qualitative variables. I just have one qualitative variable, that is red wine quality, and I will assign it just individuals. I don't will assign supplementary category and individuals. And I have my qualities according points in my score plot. I know that quality 5 has lower quality than quality 6 and quality 7. My red wines are projected in here, so I can see that inferior red wine qualities have lower total sulfur dioxide, free sulfur dioxide, while samples red wines that was top quality will have increased the alcohol content. I can see that free sulfur dioxide and total sulfur dioxide are variables correlated. I don't have a good relationship between alcohol and density you know that increased the alcohol content might lead us results in a solution with lower density. But there is a lot of things in ahead wine than alcohol. For example, a sample with high alcohol and the high residual sugars might have intermediate density. So I don't see any relation as expected between alcohol and density, and I see relations between total sulfur, free sulfur, fixed acidity, and citric acid. I have a good relation between acids contents between fixed acidity and the citric acid and pH. Uh, and I can see that top quality samples were placed on the bottom, and the lower quality wines were placed in the top. But I have some samples that don't follow this distribution. For example, I have two samples which were quality 7, a high quality red wine, that were placed together with quality 5. Well, but it is a good manner to represent your variables, and it's very simple. And the Factoshiny provide figures with high quality.